Welcome to part 2 of our Unit 2 review. In this part, we will cover adding and subtracting polynomials as well as multiplying polynomials. Once again, I'm not going to do all these problems. Do a couple in each section, and then I'll put the rest of the answers up for you to check your work. So let's start here with number 15. We've got a subtraction problem. Whoops. Let's try that again. Here we go. Subtraction problem. So when we have a subtraction problem, we need to make sure we change the signs of everything that follows. So the first polynomial stays the same. The second one changes sign, so it becomes negative 4x to the third minus x plus 6. Now we go ahead and combine like terms. So I've got an 8x to the third and a negative 4x to the third. Those combine to give me 4x to the third. Remember that all we do is combine the coefficients. The exponent and the variable stay the same. Next, I have negative 4x squared. I have no other x squareds, so I bring that negative 4x squared and put it in my answer. I've got a negative x. Once again, nothing to combine with that, so it simply gets brought over to our answer. And then finally, I have my constants, my numbers without a variable. I've got a 5 and a 6, both positive. They're going to combine to give me positive 11. Number 16, we have addition. That means no signs need to change. Everything's going to stay the same. We just combine like terms. Negative 4x to the third and positive 9x to the third becomes positive 5x to the third. Just negative 4 plus 9. Negative 7x squared and negative 7x squared becomes negative 14x squared. And then negative 9 and positive 14 becomes positive 5. Number 17, we have another addition problem. Make sure you're combining like terms. So x squared with x squared becomes 2x squared. xy with xy, positive 8 and negative 8 cancel out, which means we don't have any more of the xy term. And then finally, negative 2y squared and positive 12y squared gives us plus 10y squared. Number 18, make sure you change your signs. If you do so correctly and combine like terms, you should get negative 6x squared minus 15x minus 1. In number 19, you're drawing a model, so you're going to use these shapes up here to represent this polynomial. So for example, 2x squared would be two of the large boxes. Negative 3x would be three of these shaded in rectangles that represent negative x. And then positive 4 would be four of the small boxes. So then you can do the same thing for the second one. Moving on to multiplication. Number 20, we have a monomial times a trinomial. So we put the first term of multiplying down the side, just negative 2x. Across the top, we have 3x squared plus 5x minus 6. So I have two vertical bars here. My first area, negative 2 and 3 gives me negative 6. X and x squared gives me x to the third. Next, I get negative 10 from negative 2 times 5. X times x is x squared. Negative 2 and negative 6 is positive 12. And then I have an x from that first term, so I make sure I have an x in my answer. So this becomes negative 6x to the third minus 10x squared plus 12x. Jumping across to 23, when I have something that's being squared, I have a binomial squared that's 3a plus 4 times 3a plus 4. So when I do my area, 3a and 4, 3a and 4, I end up with 9a squared in my first box, 3a times 3a. 12a here, 3a times 4. Bottom left, 4 times 3a is once again 12a, and 4 times 4 is 16. So my answer is what's inside, so I have 9a squared plus 12a plus 12a plus 16. If the answers, or if the numbers are positive, you write plus. If they were negative, you'd use a subtraction. We're going to combine our like terms here in the middle to give us positive 24a, and there's our final answer. Number 21, you're going to use the same area that we used in 23, and you're going to end up with x squared minus 5x plus 4 after you combine your like terms. In 24, you should end up with 21x squared plus 32x plus 12. In 22, you should end up with n squared minus 25. If you do 22 correctly, your like terms in the middle should be negative 5n and positive 5n, so they will cancel out. And then finally, in 25, we have 3x plus 2 times 3x squared minus 2x minus 4. A lot of areas here. First, we have 9x to the third. 3 times 3 is 9. X times x squared is x to the third power. Next, we have 6x squared, so 2 times 3x squared. Next, we have 3x times negative 2x, which gives us negative 6x squared. Below that, we have negative 2x times 2, which gives us negative 4x. Top right, we have 3x times negative 4, which gives us negative 12x. And then finally, in the bottom right, we have 2 times negative 4, which gives us negative 8. Recognize that your like terms appear on the diagonals. 6x squared minus 6x squared, those are going to cancel each other out. Negative 4x and negative 12x, becomes negative 16x. So when we write out our final answer, we have 9x to the third. Our x squareds cancel out, so we don't need them. We have a negative 16x after we combine our like terms, and then we also have negative 8. 26, Tom's building a rectangular garden, so it's going to look something like a rectangle. The width will be x plus 1, and the length will be 2x plus 3. We're looking for the area. Area, we do length times width, so it's a simple multiplication problem. First thing we're multiplying is x plus 1. The second is 2x plus 3. So it looks just like our area models from the earlier questions, just in word problem form. The area should look like that. So when we put it all together, we get 2x squared plus 5x plus 3. Down here in 27, you're creating models. So x plus 5. Use your area model first. So we should, when we model this, we should have one x squared box. So that's going to be one of the big boxes. We should have one x rectangle. We should have 5 more x rectangles down here. So 2, 3, 4, and 5. And then bottom right, we should have 5 ones. 2, 3, 4, 5. So x squared, here's our 1x, 1, 2, 3, 4, 5 more x's, and then 1, 2, 3, 4, and 5. So this here in red is our model of our area model. So just taking what we've got up here at the top and using those to visually represent what we did for our model. So you can do the same thing for B and for C. Use your area model first and then represent your answer with the squares. That's all for our Unit 2 review. Make sure if you do have any questions or concerns, you find me before the day of the test. You can come in the morning of the day of the test. I'll be more than happy to help you out and assist you in whatever you need to make sure that you are well prepared and you do well on the assessment.